Well, all right. Hey, 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 everybody. It is 2 hours UTC, and it's time again for Astronomy Daily Live. So, this is a daily YouTube live stream on Google Hangouts that I started back in January. And it was the culmination of a number of various thoughts and the uh, not really any particular goals, just sharing a passion and creating a place for anybody who wants to come on in and think and talk science and astronomy, space, throw in a bunch of other things too, and satellites and moons and binary stars and galaxies. Um, yeah, just I I've been doing this for a number of years, but just myself, right? For me here in southeastern Arizona, it's sort of the end of the day, right? Um, get home from work, get some dinner, finish with dinner. It's like, what you gonna do, right? Uh, so what I've done for years and years and years is get onto these machines and read scientific papers and learn about things, and also, of course, do my own work. So I figured, why not share that around? It's actually super easy to do this, um, uh, and I think it's getting easier all the time. Now, the quality of this in terms of video and audio isn't really great, but things can always get better, and I think they probably will, and they will when you know pretty much exactly when they should. So for now, this the technology that I am working with. Is it really awesome? No, not really. Is it really bad? No, I don't think so. It's you know average, and a lot of things actually on this live stream that I do is I share my screen, and the quality there seems to be pretty good. But this stuff, and I'm not sure if it's the camera. I'm not exactly sure. But yeah, it's definitely not a nice sharp thing. So, but um, you know, if you can sort of you know put that aside a little bit and look at the content and the um, and the community that is growing here. um, I I think it's pretty great. So keep an eye on that, and definitely participate if you want to be on the panel, as this guy is. I'll get to him in a minute. Um, uh, if you want to be on the panel, I think that would be really great. I think having panelists here, having a lot of them, and having that kind of a conversation. I mean, this is almost sort of one way, almost, right? I mean, I try to keep track of the chat and let the panelists, get a word in edgewise once in a while. Um, uh, but yeah, I think having a lot of panelists, I think that would really um, start to make this channel uh, um, a little more unique, and interesting, and you know and it'd be less that I would actually have to say. I mean, I'm a pretty quiet dude. This is the most talking I do all day long, right? I think I say more words in this hour than I do practically all day, and I have the stats to show that too, right? I I'm averaging about 7,000 words per live stream, something like that. And so yeah, that's a lot of words. That's a lot of words. I don't think I say that many during the day. Maybe I do. Anyway, oh okay. I was just going to introduce our returning panelist. Hey there, Bobby. How those doggies going?
Hey, not much. Yeah.
Hello, doggies. They're as into astronomy as all of us are.
Yeah. I'm just trying to find.
I mean, look, what do dogs do, right? They always say, they howl at the moon, right? Well, the moon is an astronomical object. So yeah, the dogs like the moon. Cats, right? Now the cats have it figured out, right? Because they worship, they absolutely adore the sun, right? It's the sun. But there again, that's an astronomical object. So yeah, our regular pets are as into astronomy, really, more than most people are. So yeah, they'll spend hours, uh, just completely enjoying the sun, right? Or they'll spend quite a bit of time howling at the moon, right? So cool on them. All right. Well, as you may have seen, I did a little bit of a live stream. Atta, hey there. Tom, nice to see you in the chat. So so you might have seen that I did a shortish live stream a little while ago. It's so this morning I sort of finalized my first list of stars to do some photometry on, in order to continue to check out my system. And so what I did is I chose a piece of the sky that when it's dark out, when I get out there tonight, it'll be in my east. And so I chose a small piece of the sky, 2 degrees on a side, right? So four square degrees total. And I went to Gaia, right? I went to Gaia and went to the database and asked it to give me a list of all the stars in that square area that are brighter than 11th magnitude. And it came out with 38 stars just in that little area. And you know what? I didn't look to see how much they varied. I didn't look at that.
Yeah, I just we just had like an unexpected visitor just came to earlier at my house.
Oh, gotcha, good. Yeah, well, see, doggies were doing their job too. That's awesome. That's very, very awesome. So, I have a list of 38 stars, and I am going to go through each and every one of them and collect some photons. Now, this is going to be a pretty long process, because to do 38 different measurements, I want to take about 100 exposures at 2 seconds each. So it's going to take my camera. It's going to take a 2-second exposure, and then it takes 16 seconds to download. So that's 18 seconds total. And I want to do 100 of those. So that's 1,800 seconds, which is 30 minutes, right? So at my most efficient, I'm going to be able to do one object every 30 minutes. So I'm going to try to do 3 tonight and see how that goes. Maybe 4, but probably 3, hopefully 3. So yeah, this is going to kind of be a long process. But in the end, I'll have 38 stars, which is pretty good, which is a pretty good sample. So we'll see how that goes. So yeah, earlier, before this live stream, I was out and I live streamed that, taking the calibration data. I got a lot of flats, a lot of good flats, and I got a lot of darks. So I am ready to rock and roll, and that's what I'm going to do precisely after this. I'm going to get all bundled up because it's cold. It's cold. Why do these things always happen when it's cold? The only concern that I have is that there are some high, thin clouds coming from my west, and they're about halfway through the state right now, and they're kind of dissipating, but they're moving really fast, and I predict that those clouds are going to be right on top of me when I want to go out. So that's actually a good thing, because I can go out and I can look, and I can try to see if I can see anything. Now, high, thin clouds on a moonless sky is almost impossible to see, because what you have to do is you have to look for patches of darkness, right? Because there's nothing lighting them up out here. So you have to look for patches of darkness in the sky. And if it's really, really thin like that, it's really hard to see. But if I look through that, it is going to completely destroy my measurements. They are going to be totally, totally wrong. And, so I have to decide whether I'm going to spend that time or not. The most important thing, and the thing that allows me to be able to make this kind of decision is the fact that I took the calibration data, so I'm good to go, right? I've got my measurements of all the system stuff, and so if I go tonight, then I will have the calibration data I need to properly measure these things. And if I don't go, well, oh well. So yeah, that's kind of the neat thing about those clouds, is that they will be right on top of me pretty much as soon as I go out. So I may be able to see them, I may not. So I'll have to make an evaluation. If they're really, really thin, you can sometimes see them because the stars are twinkling more in certain areas than they are in others. So, there are ways to see weird things in the sky like that. So yeah, I'm just going to have to wing it. But yeah, so I've got my list. I haven't really decided which of those 38 I'm going to start with. Maybe I'll start with the brightest one and go down. So it doesn't really matter. I could start with the faintest one. It doesn't really matter. I could do a, like a pattern in right ascension, right? I can move, from east to west. Yeah, doesn't really matter. Probably what I'll do is just go from brightest to faintest. Yeah. So yeah, so I've got that going
So is that
on.
gonna be like live stream, or you're just gonna like send some photos?
Yeah, no, that that for anybody watching, there's almost literally going to be nothing to see because it's going to be dark. So your screen is going to be completely black, unless I point my smartphone at my screen, and then it's all you're going to see is just a star. So yeah, there's nothing. I don't think there's anything particularly interesting there, and really, what I like doing when I'm out like that, it's dark and it's quiet, and I can just you know relax, look up at the sky, just drift, um, and I can do that 30 minutes at a time. So yeah, I thoroughly enjoy that, and I encourage everybody to do that as much as you possibly can. You know, Try to get to some kind of actually really quiet place, um, because it's really really nice if you can get into it. Uh, so yeah, that's probably what I will do. Maybe bring some music out there, some space music. So yeah, that's about as close to heaven as I can possibly imagine. So uh, the only downside is that it's cold. So, um, but it could be a lot worse, and I've been in a lot worse. So this is the kind of cold that I can definitely tolerate because it's not really part of the equation, right? The focus is collecting the data, um, because yeah, every single bit of that is one step closer to seeing how well um, my system can perform. And my whole thought on this is that you know these telescopes are pretty good, right? I mean, in terms of optics, right? Can't say much for this this mount. Um, you get what you pay for. So I think um, for what I paid, the mount and how well it points and tracks is okay, right? If I would have paid 10 times that amount and gotten this, I would have sent it back for sure. Um, so, but the optics, I I think overall in most telescopes it is actually really 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 good, really good, such that any telescope can at least be capable of um, these kinds of measurements with this kind of precision and this kind of accuracy. Um, and so that's at least one of the things that I'm trying to prove is that just an off the shelf scope, right? I place the order, they grab the next box uh, on the shelf, mailed it out, right? So totally random. Um, so yeah, we'll see how it performs. And before I forget, I need to remember to bring this out. This is and I always forget the name of this thing. It's a mask. What's the name of
The
this?
barrel mask.
A what? Oh, I
The
remember now. A
bat
Batinoff,
dog. Yeah.
mask. So this is really really cool. This allows me to focus, um, and it's I use this for the first time on my last observing run, which I can't believe was the end of last August. It was August 29th. So it's been August, September, October. It's been 3 months since I've been doing any kind of new data collection. So yeah, that's astonishing. But you know, I was really stuck for a little while, trying to understand what I was seeing in terms of this preliminary work. Um, but yeah, no, I'm not stuck anymore, and that's why this whole project is now moving forward, um, pretty much full thrust. I want to get past this. Um, you know, I need to convince myself that this system works as well as I hope it can. Right? I would like it to be able to do, 10 to 20 millimagnitude accuracy in terms of you're right, in terms of accuracy, and about the same in terms of precision. Now, I'm not sure if I can get that. Right? I'm not quite sure. But now that I understand how I'm looking at the data, I can look at it and say, okay, I'm going to try this, I'm going to try that, right? And one of the first things I realized is that my accuracy, after about 12th magnitude or so, my accuracy gets really, really bad, right? It just gets really, really, really off. So I decided, right, okay, let's just stick to 11th magnitude and brighter, right? There are 1.8 million stars in the entire sky that are brighter than 11th magnitude. That's enough. That is definitely enough for me. So, and that's what, if that's what my system can do, as long as it can do it really well, right? I need to be able to prove to myself that this thing is doing it really, really, really well. And there are some nice indications. I've got some nice indications from the data that I've already got that for bright objects, right, I am getting into the 20, 30, 40, 50 millimagnitude range in terms of accuracy. And that's pretty exciting. And that's not doing probably as much as I can in terms of calibration. So tonight, taking the calibration data, I changed it up a little bit. So what I had been doing is I would take 10, I think it was 10 flat field images at, say, 1 second. And then I would take 10 at 2 seconds each. And then 10 more at 4 seconds each. And so I had, 30 flat field images. Not too bad, probably not too bad. And I would do a similar number in terms of darks for those flat field images. And okay, is that adequate? Well, the only way to see if it's adequate is to change that a little bit and see if I see any differences in the result, either worse or better, right? Of course, I'm hoping for better. Hello there. Come on now. Come on. Hello. All right. So, so what I did tonight is I actually got a little lucky and got out there and got started at more or less really the perfect time. Um, uh, what I want to do in terms of taking flat fields. Oh, hold on one sec. Just have to reliven my screen to reach over Kitty here. Yeah, there it goes. So this camera is a 16-bit camera. So data values can go from 0 to 65,535, right? So that's what's called um, the dynamic range of this camera is 16 bits. So at the lower range, when things are like really, really faint, and at the upper range, when things are really, really, really bright, the CCD pixels sort of behave in strange ways, right? But if you can shine enough light on there to not saturate but not be really, really, really faint, but somewhere in the middle, that is sort of the sweet spot. And so what I like to do is I like to set an exposure time for these flat fields such that the maximum value is about 2/3 of the way to the top. So if the top is 64K, then 2/3 down, let's actually calculate it. So 65535 times 2 divided by 3 is 43,690, right? So anywhere between about 30,000 and about maybe 50,000, 55,000, that range is perfect. And so what I decided to do tonight, because the timing was so perfect, I started with 1-second exposures, and that first 1-second exposure was I think a max value of about 55,000. So it's like I'm there, right? I'm there. So, but instead of setting a maximum number of a maximum number of exposures, what I did is I just kept watching the max value. And when the max value got to 30,000, I stopped it. I doubled the exposure, right? Because it's at 30,000. If I double the exposure, it's going to go to about maybe 60,000, maybe a little bit less because it's, getting darker. So I doubled the exposure, and it went up to, I think, 57,000. And so then I, let that go down to 30,000. And then one more time, I doubled it again to 4 seconds. And it again jumped up, to 53,000 or something and went all the way through. So I think in the end I got like 60 or 61 flat fields. So that's twice as many as what I have been taking. And I was in all 3 of those sets, I was going right through the sweet spot. Hello, pup. Let's see him. Hey there. Oh, okay.
No.
All right. Doggy time for Bobby. Cool. All right. So yeah, I did a similar thing with the darks as well. I doubled up on those. So I've got like 60 or 61 flat fields, which are all in the sweet spot, right? Just probably some of the best flat field data that I've gotten yet with this system. Just gotta say, because yeah, that is the sweet spot, right? Around 45,000 or 50,000 is where you want to be. And man, I moved right through all of that. It was great. It was great.
Yeah.
So
Sorry about that.
So yeah. Oh, no worries, no worries. I totally understand. By the way, I do have the dihydrogen monoxide tonight because I am hopefully going to be up for a little ways. So I figured I needed, the boost. So cheers. This is pretty potent stuff. Be careful with it. Yeah.
Yeah.
Pretty powerful for sure. So yeah, I've got the Batinoff lens here, or mask here, which it's really incredible how well. I mean, this. Look, it used to take me probably about 10 minutes to focus, right? Because it's sort of a process.
Have you been checking the chat lately?
No, I haven't been checking the chat lately. All right, we like it. Yes. That's absolutely true, Atta. Yeah. Anyway, so yeah, it used to take me at least 10 minutes or so to focus. And when you want to get onto the sky, it's just a major pain. The process is, once you're on a star, you've got to make sure that you're not saturated, and then you have to move one way out of focus, and then you got to go the other way out of focus, and then back and back, back. So you sort of go this way out of focus, this way, until you hit that peak, and that's really it's really difficult to get a good focus that way. It's just really hard.
Ow!
If you slap this thing on, right, it literally takes, as long as your star is in the field of view, right, it literally takes 5 seconds. It's that simple. It's yeah. If you're doing photography or any kind of imaging where you have to focus, this is the
Right.
this is the thing. This is when I got it, I looked at it and I said, this is a piece of black plastic that I spent $26 on. And at first I was sort of like, you know what? That's really expensive for just a piece of plastic, right? But to go from several, tens of very frustrating minutes trying to focus to 5 seconds.
Okay, so Atawada, if she's the only one who thinks a Batno fast sounds like Boris Batno from Walking and Moving.
Yeah, no, I totally get that too. Yeah, and I think it's I think there's an H in there too. I think it's BAHTINOV, I believe. Yeah, if you're just looking, right? I mean, by eye, then it's pretty easy to focus. But even then, slap this on and take a look, because the cool thing is, right, is that the pattern is really, really cool too. So you know, while you're focusing, you know, you've got your 5 seconds of focusing. You can also sit there and just enjoy, you know, the pattern that this thing makes, which is really, really cool. So yeah, this is definitely, I mean, what I do, right? I have to do a 2-star alignment in order to tell us to tell the telescope where and how it's pointing, and so that requires 2 bright stars, right? And so on the second star, when I'm done doing the alignment, I slap this on. I've already got a bright star in the field of view. 5 seconds to focus. And bam, bam, bam. I'm off. So yeah. So cheers to the Badenoff mask. Cheers. All right. Well, cool. Yeah. Maybe that is a memory aid. I don't know. Yeah, I wouldn't remember it that way. I'm just gonna have to pull it out. And interestingly, you know, when this thing came, it was bent. You know, it was slightly like that, but now it's straight. Oh, look at that! It's like perfectly flat. Huh. So, all right, well, cool. Great mask, and worth every single penny. I would pay.
Yeah,
I
yeah.
would. I'd pay twice as much for this piece of plastic for what it's going to save in terms of time and absolute frustration. Yeah, these are really, really great. Everybody should have one if you're doing any kind of imaging. Yeah.
Anybody in the chat where you can ask, do you think they still make thunder shirts for dogs?
What's that? Say that again, Bobby.
Anybody in the chat where you can answer, do they think they make? Do you think they still make thunder shirts for dogs?
Oh, like little sweaters and shirts and things.
Yeah, but it's called a thunder shirt. It's supposed to help them with separation anxiety and stuff.
Oh yeah, I don't know anything about that. Maybe somebody in the chat would. Yeah, feel free to chime in.
I heard one flaw about it. It said it didn't work for a dog. I even tried YouTube channel and it didn't work.
Well, hopefully you'll be able to straighten that out. We don't like our little ones to be too unhappy too much of the time. All right, well, cool. Let's see. It's so it's 2:39 UTC on the 29th of November, 2018. Amazing. So yeah, I've got the list of stars that I'm going to be doing over the next 19 plus hours. Not straight, just, you know, whenever it's clear. And in fact, what I'm going to do as we speak here is I'm going to reload my satellite loop and see what these clouds are doing really quick. I can't have this loop actually run because I think it likes to freeze the system too. Oh, it's starting to dissipate. Yeah, it's dissipating fast.
How fast is it dissipating?
It's dissipating really fast. Like right now, well, here, I'll just share my screen because it's, this is called astronomy drama, right? This is about as exciting as it gets. So I'm down in this area right here, right? And here are these clouds. You see them? So they start over Yuma, and they're barreling this way, right? So yeah, and see these last two frames here. Here we can stop it. We can go one frame at a time. So you see that one, and then that one, and then that one. See that? So they're starting to fade. See, watch this. Okay, so there's the most current one. Here's the previous one. There's the one before that, and the one before that. So it's definitely starting to dissipate. Well, so, and it's just a line of them, right? Behind it is totally clear, right? So, yeah, I'm just gonna, and it looks like they slow down a little bit too. So they're not going to be here in an hour. It's going to be more like an hour and a half. So we'll see. That is the drama of the moment, which is about as exciting as it gets around here. So cheers. Yeah, it's really, really hard to see those high clouds because there's nothing to light them up. So you can't see them very well. I think.
Hey, Ray.
Is Ray in the chat? Yeah. Spend the night outside. Oh, Ray. If I was a little, probably a little, well, no, I could still do it. I was going to say if I was a little bit younger, but no, I could probably still if I really, really wanted to. But fact of the matter, Ray, is that I don't have to. I don't have to. I can do this, or I can choose not to do this. So, and in choosing it, I can also choose more or less when and for how long. So, if I'm doing an occultation or something, then, I have to get up at 2 o'clock in the morning. I get up. But yeah, in general, I'm doing this for fun. So,
Oh yeah, Ottawa, you need to be younger and better to stand the code.
Yeah. Well, what happens, Atta, right, is that, and this goes along, with most of the work I do, is that I get so into it that I don't pay attention to any kind of environmental conditions. So when I'm at it out there tonight, I'm not going to notice the cold until I stop, right? And trying to knock things down. So when I stop, then it's like, holy moly, it's really cold out here. And, I can start, feeling, that my fingers and my toes are like really, really cold, where I hadn't noticed it before. So yeah, that's how those kinds of things go. Yeah, that's yeah. I remember. Here's a story. I was probably, I don't know, 13 or 14 or 15, I don't know, and had my telescope, had my 10-inch Dobsonian, all homemade except the optics and well, I guess technically the tube. So yeah, I was out. I was out observing. At the time, I was looking at the Herschel objects, which is it's a group of 400 deep sky objects that are extra challenging. Um, so I was looking at those, and it was probably the middle of winter, and I was doing my thing, right. I mean, I was finding the objects, I was observing them, I was taking notes, I was doing all those things, um, and uh, we for some reason there was some kind of a pause. Um, I forget exactly what it was, and it was at that moment that I realized that I could not move my fingers. They were, I mean, I could not move them at all. And it's like, I don't think that's very good. I don't think that's very good at all. So I warmed them up, and yeah, they're all okay. So yeah, but that you know, uh, you really have to. That sort of taught me a little bit that I did have to try to be a little bit more aware of my environment. At least check in with your body, right? To make sure that everything is attached, and hasn't chipped off or something, because it's frozen. So yeah. Keep yourself comfy, and now, okay, uh, you know, this is my thing, right? This is totally my thing. So I run the whole show, right? If I'm cold and I want to come in and get warm, I'm going to come in and get warm. If that means that I don't make another observation, so I don't. I'll do it next time. No problem. That's one of the great things about being where I am, is that we have a large number of clear nights. That's why all these major observatories are all around me, because they know that the most important thing in terms of optical astronomy is a clear sky. You got to have a clear sky or it's done, right? So many of the major observatories in the world, right, are right here, and they aren't going to put some tens of millions of dollars observatory and a lot of man hours and a lot of equipment and a lot of effort. They're not going to do all of this if the opportunity to use this instrumentation isn't maximum. So yeah, so it's a really, really great spot. And so yeah, I don't worry about if conditions aren't what I like and I'm feeling a little bit cold, then I'll shut the thing down and come in. That's all. Easy enough. But yeah, I definitely want to get at least 2 objects tonight, if not 3. I mean, I'd like to do 4, but it's going to take me some time, probably, to find these guys. The nice thing about brighter stars is that they're easy to identify. So but I've got a pretty narrow field of view. So getting to these guys is, might be a little bit tricky, but if you do if you search for these things in sort of a systematic way, you'll get them eventually. So it's going to take me 30 minutes to collect the data, right? So as soon as I push the go button at 100 exposures, I've got 30 minutes. But I'm hoping that finding the targets takes no more than 5 minutes. Um, hopefully, hopefully, the pointing will be so good that I will tell it, to go to a particular right ascension and declination, and uh, and it will slew there, and the star will be at least in the field of view. Um, the likelihood of that is extremely, extremely small. But yeah, so this is the tedious part where I need to uh, um, be gathering data to see how well this system can work. Now that I know that it is capable of what I consider to be sort of a minimum capability, um, now I want to see what its maximum is, right? I really want to see how great it can get, because my intuition is saying that it can probably be pretty darn good, pretty darn good. Um, I mean, even right now, it is good enough to do um, professional level work. That's a fact. But now I want to see how good, because I want to be better than the pros. I always want to be better, always. So cheers. No, Atta, I do use the go-to, because I'm going to specific coordinates, um, and and that at least gets me in the ballpark, and then I can systematically poke around a little bit. So yeah, I'm sort of I'm I'm in the professional mode, right? And professional astronomers use computerized telescopes to point, right? They don't want to be bothered with having to find the stupid thing, right? They just want the telescope to point so they can get their data. That's where their thing is, right? That's their journey. And the beginning of the journey is getting the data. So yeah, I will definitely use the go-to, but the pointing probably isn't going to be all that great. Excuse me. So I am going to have to hunt for them, but hopefully it won't take me too long to do that. Because yeah, I mean, I don't want to have to hunt there, for 30 minutes, trying to find the stupid little star. Yeah, well, Atta, I totally understand your thing about saving time, but I greatly encourage you to use the go-to as little as possible. I mean, if you can use it 0, that would actually be best. So I would suggest at least aiming that way. I know when you're doing a star party, you definitely don't want to have people waiting while you try to find things. So yeah, you're just going to have to practice. You're going to have to open up that sky somehow. You have to open it up and get some practice in, because that that to me is at least at that level, where you're just looking at stuff, with the eyeball. There's a lot of satisfaction in that hunt, right? I mean, it's yeah, that's part of the whole experience. Not just looking. The looking is sort of the icing on the cake. So so yeah, don't look, that go-to that go-to is very tempting. It's extremely tempting, because especially after you spent, you know, an hour trying to find NGC, you know, 653, and you know, can't find it for nothing, right? It's just I can't do it. You want to push that button, right? It's like, don't do it, don't do it. But yeah, you know, doing a star party, yeah. I mean that if you're not quick, um, then you have to use the go-to, right? I mean, there's no way around it. And as you probably noticed, people are really impressed with that, right? You just, you know, push some buttons and the telescope goes by itself. So yeah, you know, you can impress all your friends. Um, that is that, you know, Ray, that is, I think, one of the first useful uses for a Starfinder app that I've ever seen. I think that's great. You can use it as a finder scope. Wow, I like it. I like it. I might have to. I might have to load one of those apps onto my smartphone now. See if I can use it as a finder scope. That would be very interesting. Yeah, that'd be kind of interesting. All right, I'm gonna have to look into that. Ah, cool. Okay. Well, cheers again. All right. Well, yeah, yeah. No, you know, don't think of it as an excuse, though. I mean, it that's one of the great things about astronomy is that it will give you whatever you ask it. So you know, if your thing is not finding objects, you know, and spending an hour trying to find a little faint fuzzy thing, so you can, you know, check it off of a list. You know, if that isn't your thing, then definitely don't do it. I'm just I'm trying to, you know, provide a sort of a broad choice thing. So yeah, you know, whatever um, gets you going, you should definitely do. So and you know, if finding stuff turns out to be just a frustration, which I get, I get it. Um, uh, Sky Eye Pro. Okay, cool. Well, thanks, Ray. Yeah. Yeah, that is really the first time that I've ever heard of of uh, of a you know, star chart map app actually being useful, and that's a good one. I like it. I like it. All right. Well, cool. Well, as you can probably tell, I'm pretty jazzed to get out under this great, awesome black sky that I've got just out my front door, just right out. Don't have to drive anywhere. Don't have to really move anything anywhere. It's awesome. Um, all right. Well, cool. I think I am going to get out of here and out under that sky. Um, get some photons collected and make some measurements. I've got all the code to do it. So yeah, that's sort of the next step is to collect all this tedious data. This is the work. This is definitely the time of just tedious data collection, run it through the mill, and see what comes out the other side. And yeah, so yeah, and like I said, now I know what my system can minimally do, and I'm pleased with that. Right, I can definitely work with that. But yeah, I definitely want to see how good it can get now, for sure. And there are things that I can do to change it up and see, if I can, do even better than what I expect. I don't know. I've got pretty high expectations, so, and I'm extremely not easy to please at all. I'm really, really, really hard when it comes to determining if something is okay or not. And right now, where I am, I'm happy with it, but I'm definitely not finished with it. Nope. It's got to show me how good it can get now. So, yeah. Well, Atta, that's not too bad. That's not too bad. I think the average drive to a dark side is like 30 minutes. So, 5 to 10 miles. It's not. Yeah, Atta. Yeah. Yeah. Maybe. Yeah. I can't. I don't have an opinion about that. I don't know. You have to ask somebody else about that. All right. Well, cool. But yeah, you're not too far away, so that's nice. That's nice. And the only reason why I can just walk out my front door is that from the time I was 8 years old, I told myself that it's like, you know what? I've got to get out where it's dark. I've got to be out where it's dark. I can't stand this. Just can't stand it.
And no street lights, huh?
No street lights. No street lights. Nope. I'm at least according to Clear. What's that site? Let's see. Let's see. Can I look at it here? Hold on a second. Clear Outside. The site Clear Outside. My Bortle number is 2. So that's I think it goes down to 1. So at least according to the Bortle scale, which we should investigate a little bit at some point. I'm a Bortle scale 2, which is really, really dark. But it's actually not as dark as it can be. I can sort of attest to that. Yeah, I mean, I do have lights. Tucson is about, I want to say 60 miles. I'm trying to think, as the crow flies, straight line. Yeah, it's probably maybe 60-ish miles or so away. So I've got a dome. I've got a light dome in my west, but it's really low. It's really, really low. Yeah. Anyway, it's a Bortle 2, which is nice and dark. I'll take that. But all of that was planned, right? I mean, I'm here primarily because it's dark. That is like the number one reason. There's lots of other reasons too, but that's like top of the line. All right. Well, speaking of dark skies, it is beckoning. It is beckoning. I can hear it. I can hear it. It's calling me. It's just calling me in this wispy cloud voice. That I can barely see. So yeah, I'm going to go out and evaluate the sky, see what it looks like. Those clouds are actually going to be moving right over Tucson right about now. So now is a good time for me to actually go out and look, because I'll be able to see them. And I can see how bad it looks over there. So hopefully, they've dissipated. enough,
Yeah.
and we'll continue. But yeah, I think I'm going to get out there. I've got at least a couple hours of work here, so yeah, I'm glad I got the dihydrogen monoxide because it's very energizing. You can probably tell that I'm you know, extremely energized by this stuff. It's amazing. All right, so cheers, everybody. I will see you again tomorrow. I will be here again at 2 hours UTC. Make sure to subscribe if you haven't already. Hit the thumbs up, thumbs down. I've been getting some thumbs downs again, and I just like the reaction. We had a couple of trolls in here the other day, and it's like, well, that's kind of cool. That's kind of cool. We'll smash them into the ground. But I think that's a really interesting indication that um, you know this live stream knowledge of this live stream is spreading, and I definitely think that there are at least several hundred people in the world, maybe even more, but I would say at least several hundred who could definitely be a part of this crew, for sure. This live stream, I see no reason why it shouldn't. So yeah, I'm just gonna keep being here. I think that's the most important thing, and there's always something to talk about in terms of astronomy. I mean, as I say over and over again, right? Astronomy is very, very wide and very, very deep, and so there's this huge amount of area. We can talk about old stuff, we can talk about new stuff, we can talk about future stuff. And everything in between. That's why I like it so much, because it sort of encompasses a huge portion of what we're aware of, and I think that's cool. I think it's cool, and to sort of study it and try to understand it and predict what it's going to do next. I mean, that's all just kind of fun, right? And I mean, that's what a lot of science is for, is actually helping us predict the future, because we're very concerned about the future, and so we'd like to know in advance, right, what's going to happen. And if we can do that, that's pretty interesting, right? So yeah, it's the whole. If anybody has read Asimov's Foundation series, that's sort of the basis of that series, is predicting the future, and so all right, well, cool. I'm gonna get out of here. I'm gonna get out under that sky. The telescope has matched the temperature of the ambient air. The camera is still being cooled. I've got it set at 0 degrees Celsius. It's kind of arbitrarily chosen. I don't like it to have to work too hard. So I don't like it to have to cool anything more than maybe 30 degrees below ambient. So I think it was about 20 C when I started, when I turned the camera on and I instructed it to go to 0 C. So it's only having to cool 20 degrees. So I'm not stressing that much at all, because once the thermoelectric cooling dies, I've got a dead camera, no more data, no more fun. So yeah, I got to, try to take care of these things a little bit, make them work where they work best. right? Don't overstress them. Don't understress them. You know, put them right there where they like to work. And I think cooling 20 degrees below ambient is a nice, that's a nice load, right? That's not too much. It's not too little. So they're all nice and cool. I'm going to get all bundled up in a bunch of layers. Got a little hat. I got the gloves. Um, I got some heavy boot-like shoes. Um, Probably going to take the smartphone out and, as I said, you know, put on some space music, and yeah, just have a ball under the sky. So, all right, you guys, I will see you in a little less than 24 hours from now. So take care. Have a great evening, a great day, and yeah, I will be back here tomorrow, same time, same place. Take care, everybody. Bye.
Land.